All right, y'all, like I said, 8.2 is going to deal with graphing polynomial functions. All right, so we're going to start off with how can we tell what's the maximum real zeros are, the maximum x-intercepts, and the maximum turning points for our graphs. So y'all, the first thing is how to tell what the maximum number of real zeros. All right, y'all, the maximum number of real zeros are the points where the graph is crossing over the x-axis, okay? Now, this just tells us how to find the maximum number of real zeros, because sometimes you can have imaginary zeros, okay? So this is just the maximum number of real zeros. And y'all, the maximum number of real zeros is equal to the degree of the polynomial. So y'all, I'm going to throw up the chat here. So do y'all remember what the degree of a polynomial actually is? How do I get the degree for my polynomials? All right, y'all, so remember this, that degree there, the degree is equal to the highest exponent. So y'all, okay, Darren, good job. So anytime we talk about the degree, that's what we're talking about is that highest exponent. So the maximum number of real zeros is equal to that highest exponent. So then we're going to look at the maximum number of x-intercepts. Y'all, back in 4.8, when y'all had the graphs of the parabolas and it had the 2 points on it, it asked you for the x-intercepts, and then it asked you for the zeros or the solutions. So these are the same. Your real zeros and your x-intercepts are going to be the same. So if the maximum number of real zeros is equal to the degree, then the maximum number of x-intercepts equal to the degree. Okay, so those will always be the same answer. All right, the third one, the maximum number of turning points. So this is how much the graph is turning. So to find the maximum number of turning points is equal to the degree minus 1. So if the maximum number of real zeros is 7, maximum number of x-intercepts will be 7, but the maximum number of turning points will be 7 minus 1, which would give me 6. Okay? So y'all, just like them parabolas we were doing for the x squared graphs, those parabolas turned one time, but the degree was 2, and 2 minus 1 gave me the one turn on those, okay? So y'all, let me show you real quick. So if you had a parabola coming down and going up, and say this is a x squared graph, you see it's got two places where it crosses the x-axis, so that would be the two real zeros, two x-intercepts, and then it's going to turn one time, so that would be 2 minus 1 to get 1, one turn. Um, but y'all, if you had a graph of a parabola and it was moved up, this one has two zeros, but these two zeros on this graph would be imaginary because it's not crossing that x-axis. So this would have imaginary zeros. Um, but the x squared graph has a maximum of two possible. It might not have two, but that's the maximum number possible. So that's what these are sort of going over, okay? So y'all give me a second. I'm going to pull up MathLab and see what y'all do with these. Hey, y'all, and I got our chat open. So on this first one, they want you to find the maximum number of real zeros, maximum number of x-intercepts, and the maximum number of turning points. So for x to the fifth minus x to the fourth plus 6, what would be the maximum number of real zeros? Well, y'all, that's where I would look at the highest exponent. And my highest exponent here is a 5. So that means this has a maximum of 5 real zeros. You're going to check that. Then it's going to come up here and ask for the maximum number of x-intercepts. Well, remember, we said that the x-intercepts and the real zeros are both equal to the degree. So this one would be 5. Then you would check that answer. And it wants the maximum number of turning points. Well, we said that was the degree minus 1. So 5 minus 1 would give me 4 maximum turning points. And y'all, all these answers came from that highest exponent. All right, so I'm going to see how y'all do on this one. So the same thing, we're going to find the real zeros maximum, maximum x-intercepts, and the maximum turning points. So they're giving us x to the 8th minus 8x to the 7th plus 8x minus 6. So y'all, this is on y'all. What is the maximum number of real zeros for this problem? All right, good job. That will be 8. So we'll put an 8 in there and check that answer. All right, keep it going. What's the maximum number of x-intercepts? All right, so we're going 8 on that one. So Darren, looks like you need to finish this out with the maximum number of turning points. And y'all, that would definitely be 7. All right, y'all, so this next one, we're going to throw a little bit of a curveball at you. They're giving me negative 9x minus x to the 7th. So what would y'all say were the maximum real zeros for this problem? All right, it's definitely going to be 7. What they did on this one, they just threw it out of order. But good job, Darren. You're still looking for that highest exponent. All right, so that means the x-intercepts is going to be the same, right? So since y'all got 7 for the real zeros, you're going to get 7 for the maximum x-intercepts. And then what are we getting for the maximum turning points? There you go. 7 minus 1 gave us 6. So those questions will always be, the first two will always be the same. Them turning points, subtract 1 and get them, okay? All right, y'all. So now we're going to look at graphs. So the other day, we made a chart for the end behavior of the graphs. We looked at the degree being even and odd, and then we looked at the lead coefficient being positive or negative. So that chart works on these graphs right here also. I'm just making all the graphs a little bigger. All right, so I got f of x is 1/5 x squared minus 3. So they're saying use that leading term test. That's what we basically call the end behavior chart. So this has a exponent of 2 is the highest. So it's got an even degree since it's a 2. And that 1/5 is positive. So what did we pick, A, B, C, or D, when you had an even degree and a positive lead coefficient? Because y'all, the only other way to look at these is to graph them on your calculator, okay? So we're just trying to show you how to pick them out without having to graph some of these. So if you look on that end behavior chart we did the other day, this would be the even degree column, and that 1/5 is positive. So that means both ends are going to go up. So y'all would pick A. All right, y'all. So since y'all took a while on that one, I'm going to draw that end behavior chart again for y'all. All right, so you was looking at the degree. The highest exponent could be even, even or odd. Then we looked at the lead coefficient. Could be positive or negative. So that gave us 4 pictures. Even, they both went up. If it was a negative lead coefficient, they both went down. Odd with a positive went uphill left to right. Odd with a negative lead coefficient went downhill left to right. So y'all use this chart that we used in 8.1 for these problems in 8.2. All right, so here we go. All right, so both ends went up on that. And I will make these larger for you. All right, so A is going uphill left to right. B is going downhill. C, both ends are going down. You got an x to the 5th minus x to the 4th plus x squared plus 9. So the degree is 5. That's the highest exponent. It is odd. There's not a number in front of the x, so it's a positive 1. So if it was odd with a positive lead coefficient, A, B, or C? All right, A, right? Odd degrees with a positive went uphill left to right. All right, y'all. alert you to this one is x to the 4 minus 2x cubed plus 7x squared plus x minus 25. So an even degree with a positive 1. Both ends are going to go up. But y'all look here. B has both ends going up, and C has both ends going up. So I got to figure out which one I need. And y'all, I want to show you a trick. When you got a number at the end like this minus 25, and that number doesn't have the variable, so this is just a minus 25 at the end, that negative 25 is your y-intercept. That's where your graph is going to cross that y-axis at, okay? Now, down here they're telling me that the x's are going by 1 for the x-axis, and the y-axis, that y-scale, is going by 10. So I need to figure out, does B look like it's crossing at 25 negative, or does C look like it's crossing at negative 25? And Darren, you're going with B. I'm going with B on that one. Because if each of these marks is 10, that's sitting there about negative 25. So remember, if you got two graphs that sort of match, look at that y-intercept, okay? And then also, they're telling you, if you wanted to graph it on your calculator, that negative 5, 5, negative 30, and 30, that's the x minimum you would set, the x maximum, the y minimum, and the y max. And you would set that scale to 1 and 10 for the x's and y. That's if you wanted to get a graph that matches theirs perfectly, okay? All right, y'all, so let me make these larger. All right, so we're looking at the degree on this one is a 5. That's odd. It's got a negative 1 in front. So you got an odd degree and a negative lead coefficient. So are y'all going to pick A, B, C, or D? All right, so you are saying C? Yeah, because that's going downhill left to right, right? So the odds are either going to go uphill or downhill. Positive, they would go uphill. Negative in the front, they're going to go downhill. All right, y'all, so we're going to pick C on that one. All right, I'm just making them larger real quick. So we got one going downhill A, one going uphill B, both going up C, both going down D. I got an x to the 6 minus 4x to the 4. So our degree is 6, which is even. My lead coefficient is a 1, which is positive. So y'all, even degree, positive lead coefficient, A, B, C, D. All right, now, um, let's see, what are y'all saying? Okay, to get B, that would be odd because remember, odds are the ones that go uphill left to right. So since this was even and positive, Darren, what do you got? C, that would be it. If it's even degree 6, positive 1, remember both ends will go up. All right, now remember, y'all could graph any of these and just set the window on the calculator. Let me show y'all how to do one on the calculator. And then I'm going to show you tricks I do to them. All right, y'all, what are they going? The x-axis, they're going from negative 10 to 10. The y-axis is a negative 100 to 100. And looks like it's going by tens on the y-axis. And looks like they're going by ones on the x-axis. So I'm just trying to figure out what the graph looks like so when I graph it, I can get my window set right. So y'all let me share this calculator. So I'm going to go to y equals, and I'm going to put that in. I had an x, and in parentheses, x minus 4, parentheses, x plus 2, and then parentheses, x minus 5. Okay, so I got the polynomial in. Now I'm going to hit the window button and set the window according to what they had. So negative 10, good on x minimum. 10 was the x max. It went by ones. But y'all, my y minimum was negative 100. My y maximum was a positive 100. And then the y scale looked like they were going by tens. So now that I got my window set to match their graph, I can hit graph and I'll get exactly the picture I need. So y'all, we need to go in and pick the one that's similar to what I just drew. And that looks like C. Okay, so that's how you set the window. Then if you want to set it back to normal, you can put negative 10, 10 for the X's, negative 10, 10 for the Y, and make the scale 1 and 1 for both of those, okay? Now, y'all, I'm going to show y'all another trick I do on these. And y'all chat this. How many X's do y'all see here? So you see 4 X's? So that'd be like an X times X times X times X would be like an X to the 4th. And all the X's are positive. So you would have an even degree of 4 and a positive lead coefficient. And y'all, both ends would go up just like we picked on C. Okay? So I do that trick a lot instead of even graphing them. I count how many X's I got and what sign they are, okay? So y'all watch this one. How many X's do y'all think I got on this one? I know how many you see physically, but in all reality, how many are there? Because I got exponents on these, right? So for the x plus 2, that's squared, so that's like 2 x's. The x minus 3 is squared, so that's like 2 x's. And then you got an x in the front, so that's like 5 x's, which is the odd degree. Now, it's negative in the front, so that's like a negative lead coefficient. So y'all, I'm just going to make these a little larger. So, odd degree 5, negative. This thing should go downhill left to right. So we got to choose between B and D. So I'm going to show you how to tell. If you look at B, you see that left side's touching at negative 3 and the right side's touching at positive 2. Well, y'all, that's backwards. Because if you set that x minus 3 inside the parentheses here, that would give you a 0 of 3. And in the x plus 2, if you set it equal to 0, would give you negative 2. So that means this graph should be touching at 3 and touching at negative 2. Well, y'all, this one's doing negative 3 and 2. So let's look at D. D if I make it a little larger, you can see that D is touching over here at -2 and touching at that +3. So where it touches the graph will be opposite in sign than those factors, okay? Um, or you could graph it, but y'all, when you graph it, you'll be able to tell how that's going. If you remember the other day, if they had even multiplicities, they just came down and touched that x-axis, okay? Alrighty. How many x's? Well, I got 4 x's in the second one, 2 x's in the front one because that exponent's telling me how many there are. So y'all, we got 6 x's and all the x's are positive. So you got an even degree, positive lead coefficient. So that means both ends will go up. So y'all, we're looking at B or C here. Both of those are going up. Now, remember what I just did. This graph should be touching at -3 and a +1. If we look at B, it's touching at -1 and +3. So it's not changing the sign of the factors, okay? So that's wrong. So let's look at C here. C is touching at -3 right here and +1. That would be the zeros if you set those parentheses equal to 0. So y'all C on that one. Now, if you were to graph this one, you would do -10 to 10 for the x's, -20 to 120 for the y. All right, y'all, one more of these, and this one's back to being in polynomial form. All right, y'all, degree 3, +15 in the front. That thing's going to go uphill left to right. So we got to choose between A and B. Now remember when I told you had two graphs in polynomial form, that last number, the 108, that's going to be my y-intercept. So if you look at A, it's crossing right through the origin. So it's not A. And if we look at B here, oh, looks like each of them are going by 50. So that'd be 50, 100. So it's a little bit above that. So I would say that that one looks like it's at 108 and go with B. But y'all, if you graph this and do -5, 5 on your X min and max, -250, +250 on your Y min and max, and then you'll get that one, okay? And if you wanted to set the Y scale, the X's look like they're going by ones again, but the Y looks like they're going by 50. 50, 100, 150, 200, 250. So your Y scale, make it 50 on that one, and your picture will match that exactly, okay? So remember, when you got two graphs that look the same, look at that last number because that's the y-intercept. All right, y'all. So back to the pad. We're about to knock out 8.3. All right, y'all. So 8.3. It deals with polynomial division. Now, we're not going to do long division or anything like that. What we're going to do is what we call synthetic division. Now, I can use synthetic division for three things. If I was dividing polynomials, I could use synthetic division to find the quotient and remainder. Second thing I can use synthetic division for, I can find function values. Such as f of 3, f of 4, that type of stuff. Okay? And then the third thing we'll use it for is to determine if a number is a zero. Of a polynomial. So, y'all, we will use it to find function values, and we will use it to determine if a number is a zero of a polynomial. We won't be doing any problems on finding the quotient and remainder, but I wanted to put that there because we can if we wanted to, okay? Alrighty, so the easiest way for me to explain synthetic division is to work a problem and sort of write out my steps. So, y'all, my first example, I'm going to use synthetic division to find the function values. Alrighty, now, here's what is going to make this problem. When I use synthetic division, the function value is equal to the remainder. Okay, so when I'm done with my synthetic division, whatever remainder I get, that'll be what my function values are equal to, okay? So, on this one, for number one, they're giving us f of x is x to the third minus 12x squared plus 47x minus 60. All right, they want us to find f of 3, f of a negative 4, and f of 5. So this is three problems in one, basically. I've got to do synthetic division 3 times to get all these values. All right, y'all. So I'll write my steps over here as I'm going through them. So the first step, write out the coefficients. So the coefficients are the numbers in front of these variables and then that number at the end. So my first step, I'm going to write out those numbers. So that's a 1x cubed. So I'm going to write a 1. Next is negative 12. Next is 47. And then at the end is a negative 60. Now, once I write out the coefficients, I'm going to leave a little space in the middle, and then I'm going to draw a line under that. And under that negative 60, I'm going to make that like a box. This right here, this box, is going to be the remainder. Okay? So write out the coefficients, leave a little space, and then draw a line and box in the part of the line under the last number. All right, now this number here we call C. That's the number we're evaluating. So for this problem, they want me to find f of 3. So that means my C will be 3. So the second step, put in C, which is the number being evaluated. All right, now we're about to do a repetitious pattern until we get done, okay? So the first step, this first number, you automatically bring this first number down below the line. So bring down the first number below the line. All right, y'all, so I brought that one down. Now, what I'm going to do is repeat the process. I'm going to find what number goes under that negative 12. And to get that number, I take this number below the line, 1, and I multiply by my C. So 1 times 3 is 3. I put that number into the second column. That's why we're left space here. So multiply the number under the line by C and put that answer in the next column. All right, guess what you're going to do now? You're going to add the column and put the answer under the line. So y'all, you're going to add negative 12 and 3. We're going to put that answer under the line. So negative 12 and 3 give you a negative 9. And I put it below the line. Now I'm going to repeat the process until done. So any number under the line gets multiplied by C and goes to the next column. So negative 9 times 3 is negative 27. 47 and negative 27, we're going to add that and put that answer here. So that's like 47 minus 27, which would give us 20. All right, it's below the line, so we're going to multiply by C to get the next column. So 20 times 3 is 60. And y'all look at that. Negative 60 and 60 give me a 0 remainder. So that means f of 3 equals 0. Okay, so the remainder. So that's what answer you would get if you put a 3 here and cubed it, a 3 here and squared it, multiplied by 12, a 3 here multiplied by 47. If you put 3 in for all them x's, your final answer would be 0. All right, y'all, so to do f of negative 4, we got the same coefficients. 1, negative 12, 47, negative 60. I'm going to leave a little space in box under that negative 60. This time my C is a negative 4. All right, y'all, so here we go. Bring the first number down below the line. We're going to start multiplying. 1 times negative 4 is negative 4. Negative 12 and negative 4 is a negative 16. So y'all, the biggest mistake I get right here, when people add two negatives, they accidentally make it positive. But remember, when you add like signs, they keep that sign. Okay? All right, now I got negative 16 times negative 4. That's going to be a positive 64. All right, y'all. So 64 and 47. Let's add that together. So we should be getting a 111 there. All right, y'all. Last step. 111 times negative 4. That'll go into this next column. And that's a negative 444. All right, y'all. So add that together real quick for me. I got a negative 60 and a negative 444. I know that's going to be a negative something. So I'm getting what, a negative 504? Good job. So y'all, since that remainder was negative 504, that means f of negative 4 equals a negative 504. That's the answer you would get if you put that negative 4 in for all of these x's. And all right, we got one more to go, y'all. So let me knock out what's next. F of 5. So y'all, let me get this move back up. All right, so I'm finding f of 5. My numbers are still the same. 1, negative 12, 47, and negative 60. All right, leave me a little space. I'm going to box under here for my remainder. And this time the number we're evaluating is a positive 5. Well, here we go. Bring the first number down below the line. And then you're going to start multiplying and adding until we're done. So 1 times 5 is 5. Negative 12 and 5 gives me a negative 7. Then I would multiply again. Negative 7 times 5 is negative 35. 47 and negative 35 give me 12. And then y'all look here. 12 times 5 is 60. So once again, negative 60 and 60 are giving me a 0. So y'all, that means f of 5 for this problem equals 0. So I had two of them equal 0. And in a little bit, I'll show you the importance of that remainder when it's a 0, okay? All right, y'all. So this one, I'm going to let y'all sort of play with it here. They're giving me f of x equals x to the fourth minus x cubed minus 11x squared plus 35x minus 39. Now, y'all, this one, they only want me to find one thing. They want us to find f of a negative 5. So just one thing to find on this one. All right, so first write out your coefficients. 1, negative 1, negative 11, 35, negative 39. So let's write them out. All right, leave a little space. We're going to draw our line. Box off the last one. Our C will be -5. Since that's the number we are evaluating, okay? All right, y'all, here we go. Bring that first number down. So you're seeing this is the same pattern every time as far as you're always going to bring the first number down. Then you're going to multiply, bring the number over, add, multiply, bring that number over and add, and finish this out, okay? So let's see what we got. 1 times -5 is -5. -1 and -5, give me -6. All right, -6 times -5 is a +30. All right, what I got? 30 minus 11, that's what, 19. All right, so y'all, I'm going to need y'all to multiply for me in a second. 19 times -5 is a -95. All right, also, this is going to be negative no matter what because the negative's larger. So a -95 and a +35 give me a -60. All right, y'all, then let's see. We got -60 times -5. That's going to be a +300. Y'all, so I need to figure out what is a 300 minus that 39. That's going to be 2 something. So let's see if y'all got a calculator available. Add that -39. Okay, what are y'all getting? Yeah, that looks good. Positive 261. So y'all, that means f of a -5 equals 261. So y'all, this synthetic division is not too bad. You just got to get used to the pattern, okay? So now let me do this, and we're going to check and see whether numbers are zeros or not. Okay? So that's going to be next. Um, Using synthetic division to determine if a number is a zero of a polynomial. Hey, also, here's the thing. If a number is a zero, then the remainder must be zero when using synthetic division. So if it's a zero, that's a solution to setting that polynomial equal to zero. It's also the x-intercepts of that polynomial, remember, since they're equal to the zeros. So while go on them problems, when I got zeros for those remainders, those were actually zeros of that polynomial, okay? All right, so on these examples, um, they want to determine whether the numbers are zeros of the polynomial. All right, so these will start at 3. All right, y'all. So this one, they're giving me -3 and 2. So these are the numbers I'm checking. And the polynomial is f of x equals 2x cubed plus 3x squared minus 3x plus 18. So this will have answers like yes, yes, no, no, yes, no, no, yes. I'm going to check each number, and then after you check each number, you put in whether it's a 0 or not, okay? And in this one, they'll ask you, if it's not a 0, then what was the remainder that made us say that, okay? So let me check -3 first. Right now, my coefficients, I got a 2, 3, -3, and an 18. All right, I'm going to box that off. And for me to put yes, I need a 0 here, okay? So y'all, I'm going to do this first one. I'm going to bring the 2 down under the line. 2 times -3 is -6. 3 and -6 give me -3. All right, -3 times -3 is a +9. -3 and 9 give me 6. And y'all look at that. 6 times -3 is a -18. And that adds to give me a remainder of 0. So for -3, this would be a yes. So y'all, I want y'all to check whether 2 is a 0. So you got the same coefficients, 2, 3, -3, 18. So y'all, I'm going to give y'all a little time, and I want y'all to tell me whether this +2 is a 0 of that polynomial. And y'all, if you put no, give me your remainder, okay? If you put yes, then I know your remainder was 0. So y'all are saying no? All right, Darren, so let's check you. Y'all brought that 2 down. So 2 times 2 is 4. 3 plus 4 gave me 7. 7 times 2 is 14. Let's see, 14 and -3 gave you 11 here. 11 times 2 was 22. So Darren, what'd you end up with? It looks like what, 40 there? So good job. That is definitely a no. So y'all on the answer blanks, you'll pick the one that says -3 is a 0 because f of -3 equals 0. And then 2 is not a 0 because f of 2 equaled 40. So you got to put in those remainders in those answer blanks on number 3, okay? All right, y'all, so let's do that on number 4 here. So this time you got -2 and 1. And they're giving me h of x equals x to the 4th plus 2x cubed plus 3x squared minus 5x minus 1. All right, so we will check -2 first. So y'all, I'm going to write out my coefficients. 1, 2, 3, -5, and -1. And then we'll do that for our +1. Oh, y'all, so these aren't bad numbers. So y'all run that -2 and tell me, is -2 a zero of that polynomial? So if y'all remember, y'all are checking -2 at this point. But so y'all are saying no on that, and so let's check. Bring the 1 down. 1 times -2 was -2. 2 and -2 gave me a 0. 0 times -2 is 0. 3 plus 0 is 3. 3 times -2 is -6. What? -5, -6 gave me -11. -11 times -2 was 22. So let's see, 22 and -1 gave me a remainder of 21. So good job. That's a no. So y'all check this 1 for me. So is 1 a zero of this polynomial? If Darren's saying yes, let's check that out. So Darren, I'm pretty confident you're going to be able to knock these out because you're answering a whole lot of these questions over here. So I'm beginning to wonder about the rest of y'all now. So here we go. Bring that 1 down. 1 times 1 is 1. 2 plus 1 is 3. 3 times 1 is 3. Then 3 plus 3 is 6. 6 times 1 is 6. -5 and 6 is 1. And y'all look at that. 1 times 1 is 1. When you add -1 and 1, you get a 0. So that is definitely a yes. All right, so this last one I'll sort of guide y'all with. Because y'all, this last one is, they want to know, is a -3/2 a zero of f of x equals x cubed plus 1/2 x squared plus 5/2 x minus 3/2. Now, I'll tell you on this problem, be really happy that they all got a common denominator, okay? Alrighty, so we're checking a negative 3/2. My coefficients are 1, 1/2, 5/2, and then a negative 3/2. All right, since I got fractions, I'm going to leave a little bit of extra room under that, and then that'll be my remainder. So I'm still looking for a 0 makes this yes. Any other number is going to make this no, okay? All righty, y'all. So the first thing we're going to do, bring down that 1. All right, so this part's not bad because 1 times negative 3/2 is a negative 3/2. So y'all, that's basically 1/2 minus 3/2. Well, 1 minus 3 gives me a negative 2 on top over 2. And negative 2 divided by 2 makes that a negative 1. All right, then I do that again. Negative 1 times negative 3/2 is going to make that a positive 3/2. All right, so now we're adding 5/2 plus 3/2. So the bottom will be 2 at this moment. So on top, 5 plus 3 is 8. And y'all look at that. 8 over 2 gives me 4. So now the trickiest part is multiplying 4 times negative 3/2. So that's negative 3/2 times 4. And if you want to put a 1 under the 4, you can to make it look like a fraction. Because remember, fractions multiply straight across. So negative 3 times 4 gives me negative 12 over 2 times 1, which is 2. Now, I'm just going to show you a trick. I'm going to leave this like that since this number has a fraction with a 2 under it. I'm going to leave that as a negative 12 over 2. Y'all, because if you make that a negative 6, then you're going to have to find a common denominator to add them together, okay? So I'm going to leave it as a fraction, and I got negative 3/2 minus 12/2. Well, y'all, no matter what, there's no way this is going to equal 0. So let's see, the bottom is 2. Negative 3 minus 12 would give me something like a negative 15. So that's not a 0 anyway. The only way I'd have got a 0 is if this last thing being multiplied gave me a positive 3/2 there, okay? So y'all, this one for me was a big no. All right, y'all. So I will say this. Support is doing the same thing. It's got 3 problems in support. One about the zeros, and then some doing the function values, the F of stuff. So, but it's synthetic division doing just like we were doing, okay? So y'all, let me ask y'all, do y'all got questions over this? So any questions? I sort of like that synthetic division. Once you figure out, bring the first one down, multiply, bring that number over, add, take that number, multiply again. It's just a repetitious pattern there. But once you get the hang of it, you'll get really good at it, okay? Oh, yeah, I'm just checking to make sure I got everybody here so far. 1, 2, 3, 4, 6. All right, I got everybody down. All right, y'all, any questions at all about tonight? All right, then, guess what? Give me about an hour. I'll get that video sent out to you. And y'all, we don't meet next week. Y'all actually get spring break next week. So If you're behind on anything in this class, I would definitely use spring break to catch up, okay? All righty, so y'all have a good break, and I'll see y'all. Oh, it might be like March 30th when we come back. I'm not sure. Might be in April, but I think it's still March. I think it'll be like March 30th. So y'all have a good break, and I'll see y'all March 30th.